Okay, let's do an example for Bayes' theorem. Actually, the first example, which is guessing a neighbor's child's gender, specifically if you already know one of the children's gender. So here's the case. So your neighbor has two children, but you know that they already have at least one boy, maybe because you saw them or saw the boy playing in the garden. But you don't know the gender of the other child. So the gender of the other child could be a boy or a girl. And what you want to know is what's the probability that your neighbor has a boy and a girl, knowing that they already have at least one boy. So that is not 50-50. Because the question is not what's the probability that your neighbor has a boy and a girl, but the question is what's the probability that given that they have at least one boy, that the other one is a girl. So then by Bayes' theorem, this is what's the probability that the other is a girl, times the probability, given that the other one is a girl, that they have at least one boy. Well, you already know that they have at least one boy, over the probability of having at least one boy. Okay, so let's figure out what the probability of having at least one boy is. So let's say your neighbor can have two children. So the first child could be a girl or a boy. And the second child could be a girl or a boy, girl or boy. Okay, so the entire relevant set of having two children could be that you have two girls, then a girl and a boy, then a boy and a girl, and then a boy and a boy. So those are the four ways we can have two children: girl, 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 boy, boy, girl, boy, boy. Well, if the question were what's the probability that your neighbor has a girl and a boy, well, it would be 2 girl, boy, boy, girl out of the 4 possible ways of having two children, because it will rule out girl, girl, boy, boy. So it's 2 over 4, 1/2. But our relevant set is not the 4, because we can already rule out that your neighbor has 2 girls. So that means we have to conduct our analysis to this subset. Girl, boy, boy, girl, boy, boy. Those are all the ones that include at least one boy. Okay, so now we can see that the probability of having at least one boy is 2 over 3 out of the total of 4. So the 3 in the orange box over the 4 in the total set. Okay, then what's the probability that the other is a girl? Okay, so that's 1/2. You already know they have a boy, or the other one is a 50-50 chance that it's a boy or a girl. So that is 1 over 2. And now here, that's probably the most interesting. What's the probability that given that the other one is a girl, that there is at least one boy? Well, you know there's already one boy, so that is 1. So you don't have to worry about that one. So that probability is becoming 1. Okay. So the numerator becomes 1/2. The denominator becomes 3 over 4. And that is 1 over 2 times 4 over 3, which is 2 over 3. Okay, well, so we could also write that. So this is Bayes' theorem, but you know, this is also, we could have written it, what's the probability of the other, a girl, at least one boy over the probability of at least one boy. So now we derived here this probability in the numerator, which is 1/2, using Bayes' theorem, but we can also derive the numerator with 1/2 using again this example here. So what's the probability that there's at least one boy and the other one is a girl? Well, that is just girl boy and boy girl, so that's 2/4, so that's also 1/2. And to be complete, we could also display it in a Venn diagram. So let's make a Venn diagram. So let's say we have two events. So let's call that the other is a girl, and in blue at least, so this is at least one boy, and the first bubble is other a girl. So let's go through this set again, and let's put that information into, there was a girl boy. Okay, girl girl, well, the other is a girl, but there's not at least one boy. So the GG, girl girl, goes into here. Girl boy is at least one boy, but that's also the other is a girl. So here we have girl boy. And boy girl, same thing. We have at least one boy and the other is a girl. Boy girl. And at least one boy is BB, boy boy, but there the other one is not a girl, so that goes into here. Boy boy. Okay, so now we see that the interaction, the probability of the other, a girl, and at least one boy, it's those two 4 in the intersection over the total of 4, so that's the 1/2. Okay, so so that was like one example, and in the next one, let's do another famous example about using Bayes' theorem. But let's just stop here and then start a new video for the next one.